So in this demo, what we'll show is all the voucher functionality that has been created. So firstly, we will look at the UI and the voucher functionality within that, and then we will move on to look at the APIs and how they work and how we test them for load. So firstly, let's look at how you can see voucher status in the UI.
Then we have this part for vouchers, okay? The vouchers is a set of instructions that I can send to the backend services. In this part, very similar we have in the account management. In this first part, we will able to see the current vouchers that we have in the system for now. I mean, with this data, serial number, the vouchers mean when this voucher was added to the system, based maybe with the API or maybe with this option that we will review, creating a voucher, government entity, functional ID, and the status of this request. I mean, we could have some inactive, active, canceled status mainly for these vouchers in general here. So this is just for query the information that we have related for vouchers.
So as you may have noticed, functional ID was not showing. So we applied a quick fix as to how the IE was viewing that data, and this now shows the results.
Okay, I have updated the input, the attribute name. So we have these values now. In the case that we have not here an empty value is because that row or that request has not this value. Okay. Well, let me go here. Let me prepare a new file with new transactions. Hold on a second. Okay. From the create vouchers part, is one of the two sections that we have this option to upload a file with some specific layout. The layout can be downloaded by the user if they have not this on hand. They can click this download template. This template is downloaded locally and maybe they can to upload to some cloud or maybe process this with some other spreadsheet tool like Excel or other similar tools,
Mhm.
uh, and fill it this file has this structure as I will show you here, right? In the case for vouchers, we have 7 columns. The 7 columns are institution ID, voucher group, currency, amount of these transaction or instruction, sorry, expire, pay function, functional ID, and narration that works as kind of description of this individual instruction. So these are some sample files here. So that is in general how looks this template for this voucher part. Okay.
Mhm.
So how I can proceed with this? Practically, I can drag and drop the file on this area, or I can browse the file in this case, and the file is presented here uh, 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 because the user will be able to review it in a preview way to be able to present the data that exists in this file. The process needs to have two other inputs, a part of the data presented on the file. We have the request ID. The request ID is a random number generated by the system now, but if the user wants to input a different value here, he will be able to add it. Okay. And the second data is to use a URL for callback. The callback, as we know, is a way that the different backend services has to communicate the progress of the result of this batch or bulk process. Okay. If the user does not want or is not the right file uploaded previously here, he has the option that clear the data and go back to the previous view and reload the file that he needs to upload. Okay, that is one option. So if the data presented here is fine or is right based on the input file selected, we are able to send this data to the backend. And as we have here, we have received a success message that the backend has received our request with this data. We need to wait sometimes in order that we can review this instruction. Maybe is this one, the latest one. We need to review this. And that is how we can work on these create voucher instructions here in general. Okay.
Is that passing functional ID okay? Because I notice the ones at the bottom that you've just created don't have the functional ID on it. Similarly, a fix was needed just to make sure that the UI was passing the functional ID to the backend services through the API correctly. So what you now see is a file being created with some vouchers with functional ID, which we'll then pass in through the API, and you'll be able to see the functional ID has been received by the system correctly.
Okay, we have here these three. I will send this. We have the success here. And yes,
that's now showing.
that works. Okay. Again,
Thanks for that. Just to clarify, all these fixes that you've seen here were not to the APIs themselves, but were actually how we were calling them with the UI. And these fixes were then merged into the v1.13 release, which is what's been loaded into the GovStuck sandbox and is our final release. So now we move on to look at the Vouchers API in more detail and how it's called and how it's integrated with the ID account mapper.
Moving on, the second API that we integrated account lookup is a voucher API, particularly like voucher redeem and pay API. And this API account lookup happens like in this particular flow, the account lookup happens and the response from the account lookup is sent to the transfer API. So I'll start with creating a new voucher here. Just change this. So I've given a callback URL here. So that is the webhook site. The callback should come there. Let's go ahead and I'll go ahead and activate this voucher. Yeah, I got a successful response on activating. I'll use this voucher number to redeem the voucher now. Yeah, we got a callback. And here we have a transaction ID that is equivalent to the client correlation ID of the transfer API. So we'll go ahead and pull this using the client correlation ID here. And the tenant will pass as yeah, as you see, like the status is completed for this particular transfer, which is initiated from voucher, redeeming the voucher, and we have a pay party ID is as 8, which has come from the account lookup.
So now we'll show you how load testing was done on the redeem and pay API for the vouchers.
So here are some Word docs that contains the load test and its result. This includes the API like voucher redemption and pay, as well as the batch transaction API. So as showed in the beginning, to create and activate the voucher. So for that we automate that thing and generated vouchers in the bulk, so that we can perform load tests on top of it. So here are some memory configuration. You can see with this memory configuration, we have performed a load test on voucher redeem and pay API. So there are some scenarios we have performed, like 500 transactions with 5 requests per second. So with this scenario, we got 500 transaction with all callbacks, and this all this transaction is load test is done in 3 minutes 52 seconds with 2.1 TPS. Here are some load test result for that. We have used a JMeter UI here. Yeah. So here you can see the configuration of the load test, like 500 threads. It will run 500 threads in 100 ramp up time.
Are you able to zoom in just a little bit?
Yeah. Okay. I'm just zooming in. Yeah. Can you see now?
Yeah, thanks.
Yeah. Yeah. So these are the load test configuration, and its results are also there. The summary report of the load test. This contains the uh, request per second as well as the TPS. There are some these are the load test, and this also contains the assertions. If all the callbacks are received, then our callback is sorry, our load test is passed. Otherwise, JMeter load test will fail. There are some failure scenarios. Scenarios are also there. We can see at the last of this documentation. So here is the response time graph for 500 transaction for voucher redemption and
Yeah,
pay.
yeah. So the challenges with these graphs is like we are not looking at these graphs at all. Why I will mention? Can you scroll up to the summary?
Yeah, we can go with that.
Yeah, yeah. Just keep it at the summary. Okay. Yeah. Not this. The JMeter summary.
Okay. Yeah, yeah.
Yeah. So so all the metrics here. The problem with JMeter is giving the metrics from a synchronous point of view. So it expects, we have implemented the callback, and the summary in the top is not matching with the summary in this report. So the reason for that primarily is the time taken by each transaction, the callback. So average response time per transaction, calculating that is tricky in JMeter. We have done it with ngDoc, but this test report doesn't show that. So all this throughput it's showing in the fourth last column, it's JMeter by default assumes each API to be a synchronous API. So it's when the request comes back with a response, it's assuming the processing is completed, not when the callback is received. So yeah, so if polling APIs are there, then it's slightly easier to calculate the TPS accurately. Right. So 2.1 TPS isn't an accurate measure because we are taking the total number of transactions and dividing it by the total time taken. Instead of taking the average response time, multiplying it with the number of transactions, right? And yeah, and then dividing that by the total number of transactions. So there, the TPS here, some of this is requests per second. So the distinction between requests per second and transactions per second is there, but the numbers are not. The summary we have written is based on the results JMeter is giving, but this summary data is not shown in the JMeter reports themselves.
Okay, I think I get that. So it can cope with 5 requests per second, but actually you need to do 2 requests per transaction, which is why you're at 2.1 transactions per second. That's roughly what you're saying, isn't it?
Yeah, to summarize it in another different way. So here, one transaction could have started at the first second and finished at the second second, and another transaction could have started at the at 3 minute 51 second and ended at 3 minute 52 second. So
Yeah.
that way, if we calculate the average response time and multiply it with number of transactions, the TPS would be on the higher side. So that is easier to do with polling APIs rather than with callbacks. So this TPS isn't accurate, and the 20 requests per second is since the configuration we are using is for the bare bone chart, where 256 MB has been allocated to vouchers and 16 GB overall payment of namespace. So 20 requests per second is a ZBay limit we have introduced because it's not a load testing environment. Uh, So ZBay can process, of course, a lot more than 20 requests per second. But in order to keep the failure rate zero, we have kept it as 20 requests per second as the ZBay configuration limit. Yeah.
And the primary constraint was memory, though. So if you like doubled the memory across all of the sub-services, you probably expect to get 40 requests per second before you'd have to start throttling it again to stop failures.
Yeah. So in the voucher flow, I can tell some parts for which we have done to increase the TPS. It's not showing in this summary report. So can you show the BPMN level?
Yeah. These are the update in the BPMN.
Can you zoom in slightly?
Yeah.
Yeah. So so there were 2 asynchronous integrations in this. One is the account lookup, and other is the transfer. So to make it more closed loop and to reduce the time, now account lookup API was made asynchronous in case it needs to look up an account in another external Oracle. But in the demo instances, account lookup is an internal call, so it need not be asynchronous. So we have introduced one more flavor of the account lookup API, which gives a synchronous response. So in the first call itself, in the pay account lookup, it gets the response if external Oracle is not enabled. So that reduces the time. And the transfer API also, the callback from the transfer API or polling the transfer API status, that part also we discussed with Shovan, that this is a in voucher redemption, it's a payment advice. So the redemption status would be redeemed regardless of that transfer is successful or not. Right, like the retry mechanism has to make it successful. But from a voucher redemption status, once we get a accepted status from the transfer API, the voucher will be marked as redeemed, and this callback would be sent to the test, or the load test harness. So these are where we made it into a closed loop with a less time waiting for callbacks from other APIs. Yeah, slightly different scenario here. We're getting 4.3 TPS. Uh, we have increased the request per second from 5 to 10. Right. Yeah.
Yeah, here is the summary for that. Geometer summary. And here it's 4.3 per second.
Okay, but you've not increased the memory at all to do that. You've just literally increased the rate you're pushing them in.
Yes.
Third scenario is for increasing the request per second to 20, from 10 to 20. And the 5.8 TPS, and it was completed in 2.52 seconds. Yeah. Here are some geometrical summary.
Yeah.
And the next scenario is for 29 requests per second for 1,000 transactions or 1,000 vouchers. And this is the last successful result we got with this request per second. After that, it starts filling with the request per second. It's just a configuration thing. We can increase that thing also.
So that's still on the bare bones infrastructure at that point in time.
Yes.
Okay.
We just tried to increase the ZBA request per second limit from 20 to 30 and see if the failure is increasing from 0% or not.
Yes, we know 29 is the sweet spot now. Okay. Yeah. And all the load test documentation shown in this example can be found on the GovStack conference under load testing results.